Advanced topics. In this particular section, we'll cover some advanced topics in Swift, including generics and higher order functions. These concepts will help you write more flexible, reusable, and powerful code. Now, generics allows you to write flexible and reusable functions and types that can work with any type, subject to requirements that you define. They enable you to write code that avoids duplication and expresses its intent in a clear, abstracted manner. Let's look at an example for generic functions. A generic function can work with any type. You define a generic function by placing the type parameter in angle brackets after the function name. So for example, here I can say function after the name, which is, let's say, swap values. I can just say t underscore a equal to in out is something that we did before, in out variables, where you can pass the address of the variable in out t. Now this t can be anything, any type that you have. Now I can say let temp equal to a equal to b, and then b equal to temp. Once I have that, I can say variable x equal to, let's say, 5, variable y equal to, let's say, 10, and I'll say swap values. In this particular case, I'll say the first one is and x, and the second one is and y. Now if I try to print these, the value of x is, let's say, x, and value of y is, so y. Let's see if this works. So if I run this, x is 10, y is 5. So no matter, I don't have to specify. Even in this case, if I have, let's say, a variable string 1 equal to hello, and I have a string 2 which is world, I can say swap values and string 1 and string 2. Now I can just do the same thing. String 1 is string 1 and string 2 is string 2. Let's see if it worked for strings, and there you go, world hello. So it swapped them. Now let's look at generic types. A generic type can work with any type. You define a generic type by placing the type parameter in angle brackets after the type name. So for example, let's start here with a struct which is called stack, and the generic type of, let's say, element. Now inside this I can have private variable items of the type element equal to empty. Next I have mutating function push, and this has an item element, and then inside this I am gonna say items dot append, and I'll pass the item as the element. Next I can have another mutating function which is the pop. Again same, in this case we'll probably pop elements, so this will give you an element, and that element I can just say pop last. So function, make sure you have that this way. And now if I want to look at this in action, I can create in stack integer stack equal to a stack of which element is it? I can just say it's an integer element. So I create a stack based on this structure that we've created, and inside this I want to push, so I can just say int stack dot, not pop because there's nothing in there, push 1, push 2. I can just say print, print popped item is, and I can say int stack dot pop, and I'm sure there is some value because I've pushed 2, so I'm gonna say exclamation mark here, which is, it has a value, because if you see my stack elements here, when it pops it has an optional value, so I'm gonna force unwrap it. Next thing I can do is, if I run this, probably see popped item is 2. Now I can say string stack, I can create a string stack by saying stack of the type string this time, and same thing, I can just go and push a string, say hello. I can string stack push another item, call it world. Now I can say print popped item is string stack dot pop. If I run this, oh, forgot to add the exclamation mark here, and that's why it's showing optional world, and you want to see world, and there you go, we have the world. So this is how you can do generics, and a good example over here that you see. Now let's look at higher order functions. Now higher order functions are functions that take other functions as parameters or return functions as the results. They are a key feature of functional programming. One of the example that I can talk about is map. So let's look at how map works. The map function transforms each element of a collection using closure you provide. So for example, let's say if I have an an array of numbers which includes 1, 2, 3, 4, and 5, and let's say the squared numbers for all these numbers in this particular array, I can just say numbers dot map. What it does is, it will go through each and every element and create a new array based on the calculations I say ask it to do. So I'm going to say take the element and multiply it by itself. Now if I print this, I will see squared numbers are slash squared numbers. Now if I run this, you'll see an array of 1 times 1, 2 times 2, 3 times 3, 6, 4 times 4, and 5 times 5. So that's how you can use this map filter to go through each and every element and then transform them. Next we can look at another one of my favorite, which is the filter function. The filter function returns an array containing only the elements that satisfy a given condition. So using the above array, I can just say I just want to get even numbers from there. So I can say numbers dot filter, and this inside this, this is a different filter, but filter, I'm going to say take the number mod 2, and if equal to 0, then give me back that number, which is all the even numbers. So I can say even numbers is even numbers. There you go, run it, and you see I only have 2 and 4 in this particular case. So that's how filter works. You can create your own kind of logic here. Whatever closure you put here, it will process that. Let's next look at reduce. The reduce function combines all elements of a collection into a single value using a closure. So if I want to get sum of all the numbers in there, I can say sum equal to numbers dot reduce, not this one. So here reduce up, let's take the element reduce, and inside this I'm going to say dollar 0 plus $1. So it will keep on going through the element from 0 and then keep on adding them. So if I say print sum is sum, run this, gives me 15. 5 plus 4, 9. 9 plus 3 is 12. 12 plus 2 is 14. 14 plus 1 is 15. So that's why I have a sum of 15. So these are some of the higher order functions that we have. Now if you want to use whatever we have learned here, let's go over a walkthrough of the entire thing that we did for our generic functions and higher order functions into a single function. So you can walk along or work along with whatever I'm doing here. So first I'm gonna go over generic functions to find a maximum number. So I'm gonna create a find maximum generic function t, which is comparable, which kind of it inherits from comparable, and it takes, let's say, a, which is again t, and we have underscore b, which is t again, and this replies back with the type t back. And then here what happens is I'm going to say return if a is greater than b, question mark, a or b. So if a is greater than b, then return a or else return b. So that's what it does here. Now let's go ahead and say let max int equal to find maximum, and here I can give 3 and 7, print max integer is max int. Let's run this, and we have max int is 7. So that's how this can work. Next what we can do is we can use the same above thing. Now we did for integers, we can use the same thing for string. We can say max string equal to find maximum apple and banana. I'm providing two different fruit names, and I'm saying print max string is max string. Not int, string. Now output will be banana because that's the maximum string as compared to when it does calculation. If I run it, it says max string is banana. So another thing that we can do is create a generic stack. So I can create a struct with a generic stack which takes the element type here, and inside it I can say private var elements is of the type array of element, initialize it to empty array. And now let's create mutating function so we can push items inside it as we did in our example earlier. It will take element, the type element, and what it does is it goes into the elements and appends a new element that was passed. Now similarly for pop, mutating function pop, which gives us the element back. In this case what we do is return elements dot pop last. So what we'll call the type element must be unwrapped elements dot pop last. It looks fine to me right now. Let me see if it looks fine to me. Let's go ahead and try to see if it works. variable number stack equal to, let's create a generic stack of integer elements. Now number stack dot push, I'm going to push an element, let's say 10. Do that again with 20, and now I'll say print, just going to print it out, let's say number stack dot pop, and I'll have to make sure that this is up. I think that's the problem here, supposed to be optional. So there you go, 20 is what is popped out. um, Next what we can do is, let's look at the higher value, where we have values equal to say 1 2 3 4 5 and 6. Now I want to create doubled values. I want to double each and every value in there, so I can use that map function, double values equal to values dot map, and if I want to double it, I just say $0 times 2. So this will double the values. I can print it saying double yes, it's a print here, that's why double values, run it, and we have a array with doubled values. Next we can look at the filter. Let's get the, we got the even numbers before, let's get the odd values this time. So we can say values dot filter, and inside filter I can say dollar zero mod 2 is not equal to 0. That's what will give me the odd numbers. I can say print odd values. Let's run it just for the fun of it, 1 3 and 5. Next what we can do is we can get the total sum, same as before, total sum equal to values dot reduce, and inside this I can say from 0 to plus. Just the plus can sum up all the different functions. You don't have to write the entire logic for it, and I can say sum is total sum, run it, and we have sum of 21 right after this. So you can go ahead, and last time we did that 15 plus 6, so that's 21. So in this particular section you have learned how to use generics to write flexible and reusable functions and types. You explored high order functions like map, filter, reduce, and map, filter, reduce, which are powerful tools for functional programming. Now generics and higher order functions are advanced topics that greatly enhance the flexibility and power of your Swift code. So if you have any questions on whatever we did till now, post them in the comments and I'll get back to you.